Tonight's another review of surface area that you learned in 6th grade, and you're probably starting to say to yourself, wait a minute, what's the 7th grade piece of this? Well, I promise you tomorrow night we're going to do surface area of composite figures, and that will finally bring in the 7th grade piece. But I figured it's been a full year since you did surface area at the 6th grade level. That's why I'm spending so much time reinforcing it. Okay, so the objective is I can find the surface area of three-dimensional figures. Tonight's focus is going to be on pyramids. So when you think of pyramids, you might think of the pyramids in, where is it? The deserts of Egypt, right? Those are square pyramids, and they're called square pyramids because they have a square base, or you call them rectangular pyramids, and all the other faces, all those lateral faces will be triangles. So you could also have a triangular pyramid. This little game, it's a little puzzle game that was out when I was a kid, and it was made up of all triangular faces. So that would be called a triangular pyramid. You could also have a hexagonal pyramid. Pyramids are named by the shape of their base. So their base names them. So the base of this is a hexagon. In a pyramid, all other faces are triangles. A rectangular pyramid, like the ones in Egypt, has a rectangular base and all the other faces are triangles. Heptagonal pyramid has a 7-sided base. All other faces are triangles. So in prisms, where all our lateral faces, the faces that aren't bases, were rectangles, in pyramids, all of those extra faces are triangles. It's named by its base, and all other faces will be triangles in a pyramid. All right. Let's go ahead and look at some. So here's a tetrahedron, a triangular pyramid. Here's what it would look like. If you're doing the kite project this year at school, I don't know if the teachers are doing it, but you build a kite, and the kite is made out of tetrahedrons or triangular pyramids. So to find the surface area of any three-dimensional figure is just the sum of the area of all its faces. It's like if we're wrapping it up, how much wrapping paper would we need for the outer coating? And so we just find the area of every face, add them up. So the first example says, find the surface area of the following pyramid. It may be helpful to use the net provided. So in 6th grade, you did a lot with nets, and you used the net to help you find the surface area of a figure. This year, probably if you're given a figure like on a test or a state test, final exam, it's going to be three-dimensional, and you'll either have to peel back those faces and draw the net yourself, or you'll have to be able to pull it apart on the actual three-dimensional figure. So if I look here, the base is this beautiful triangle. So I'll have to find the area of the base, which is a triangle. So it's the area of the triangular base. We know the area of a triangle is area equals 1/2 the base of that triangle times the height of that triangle. So I know I use the word base interchangeably. I'll make this a capital B. The base of the figure is this full triangle. And then there's an edge length here that is the length of the base of that triangle. It's interesting in math. We use some words that you're like, well, wait, why are you using the same words? It's just what we do. And a lot of times when we're talking about the base of a figure, we use a capital B. All right. So the base of this triangle is 10. The height, because it has to meet it at a right angle, is 8.7. So the area of that pink, I'll put pink so you know, is 1/2 times 10. Oops. It's a 10 times 8.7. Meters times meters will give us meters squared. So half of 10 is 5. 5 times 8.7. Let's see what that is. I'm going to use my calculator. You don't have to, but I need to use my calculator to make this a little bit quicker. 5 times 8.7, 43.5. And that seems reasonable to me because 43.5 meters squared. I like to estimate. So 5 times 8 would be 40. So 5 times 8.7, I have no problem with the fact that it's 43.5. It's somewhere around 40. All right. So we've gotten this base. Now you would have to, if you looked at it with the 3 dimensions, you'd have to focus in on the base of it, and you'd have to say, okay, they tell me that height right there is 8.7, and that base is 10. All right. All our other faces will match, which is beautiful on a pyramid. All the other ones have to match, so they meet up at a point. So now we're going to find the area of our blue triangles. And the beautiful part of that is those will match. So if I find the area of one of them, I just have to multiply that final area by 3. So now it's 1/2 times the base of my blue triangles times the height of my blue triangles. So that's 1/2 times the base of my blue triangle. Again, if I look here, the base of my blue triangle must be 10. They all have to match. The base of my blue triangle is 10. The height of my blue triangle is 14. All right, 1/2 times 10 times 14. Half of 10 is 5. So you just do 5 times 14. I don't know, what's 5 times 14? 5 times 14 is 70. Sounds good. 5 times 14 is 70. That gives me the area of 70 meters squared gives me the area of one of my blue triangles, but I say I have 1, 2, 3 blue triangles. They all have to match. So I'll just take 3 times my 70 meters squared to find the area of all 3 blue. 3 times 7 is 21, so that must be 210 meters squared. So that's for all 3 blue triangles, the area of all 3 blue triangles. I have the area of my pink triangle. So the overall surface area, I got to add up the area of all those faces. So I take my 210 for the 3 blue. I add that to 43.5 for that pink. And what's 210 plus 43.5? I bet I can do that without a calculator. I bet it's 253.5 meters squared. Right? Sounds reasonable. All right, so hopefully that's a nice reminder if you're having to find the surface area of a triangular pyramid. Let's also look at a rectangular pyramid for tonight, and then tomorrow night we'll put them together and look at some composite figures. All right, calculate the surface area of the square pyramid. Okay, so now we have to find the area of the square base, and then each of our triangles will go ahead and match. So then we'll have how many triangles going around the square base? We'll have 1, 2, there's a third one in the back, and a fourth one over on this side. If there's 4 sides to the bottom of our base, we know we're going to need 4 triangles to meet up at that point at the top to make the pyramid. Okay. So we're going to do the area of our square, which happens to be our base. This is a square pyramid. Area of a square is side squared, or base times height. So if you look at the dimensions of that square, you can see it's 8 by 8. 8 times 8 is 64. Oh, these are centimeters now. Centimeters squared. And then we're going to have to find the area. I'll just do one of my triangles. They all have to match. Okay, the base of each triangle is 8. The height of each triangle is 5. They have to meet at that beautiful right angle. So we have 4 matching triangles. So I'll do area equals 1/2 times base times height. That's 1/2 times the base of our triangle is 8. The height of our triangle is 5. Half of 8 is 4. 4 times 5 is 20. So 20 centimeters squared would be the area of just one triangle. I have 4 of them. So off to the side, I do 4 times 20. 4 times 2 is 8. So that's 80 centimeters squared. And that represents my 4 triangular faces. So to find the entire surface area, I take my area of my square, 64 centimeters squared. The area of those 4 triangular faces together was 80 centimeters squared. I believe 8 plus 6 is 14, so is that 140? Oh, 144, sorry, my bad. 8 and 6 is 14, so that would be 144 centimeters squared. 64 and 80. 4. 8 and 6 is 14. 144 centimeters squared will be the entire surface area of that beautiful square pyramid. So hopefully you're starting to see whether it's a pyramid or a prism. All you have to do is take the area of each face and then add them up. So the big part is being able to visualize the dimensions of the faces. Nice things with these pyramids is those triangular faces on a square pyramid or a triangular pyramid are going to match. All right, hopefully that helps. A reminder from 6th grade what you learned about the surface area of pyramids. Have a good night.